Okay, so we're finding the distance between 2 points on a coordinate plane. And it says, assume each interval on the graph represents 1 unit. Find each of the following segment lengths by counting. If not possible, explain. Okay, so we're going to find the distance or length of AB. This is AB. Well, if each segment length is 1, and I see 1, 2, 3, 4, 5, 6 segment lengths, how long is segment AB? Well, each one is 1 length, right? So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So that makes a total of 6. So the length of AB is 6. That one's pretty straightforward. We can count each segment clearly. Take a look at AC, though, this diagonal length. We run into a problem, right? Like this first length here, from here to here. Can I say that's exactly one unit? No, it's on a diagonal. If it was vertical, straight up and down, or horizontal, straight across, yes, that's either way, that would be 1. But here on a diagonal, that's tough. And then for the next piece right here, look at that little tiny bit right there. Can't measure that. I can't tell exactly what that length is. So can we find this length at the moment? AC? No. Yeah, we have a problem. At this point, it's not possible. Explain how a right triangle could be used to help you answer part B, this one. How could I use a right triangle to find that? Is there a right triangle I can use? I can make one, yeah. Let me show you. Suppose I go like this. Go straight down, straight across. Kind of like we did with finding the slope, rise over run. We always formed right triangles, didn't we? All right. So if I just made a right triangle, how is that going to help us find length AC again? What do you think? Yeah, the legs. The legs, we can measure the legs, right? We can say, for example, this is maybe 6, and that's maybe 8. We can measure those. But how does that help us find AC? Yeah, that's a hypotenuse. You could just say that's C now, and 5 squared plus 8 squared equals C squared, and we can find that length. So let's finish up this sentence. So a right triangle could be used to help answer part B by using our favorite theorem, the Pythagorean theorem. we're going to use the Pythagorean theorem. So here's the thinking behind this. This is distance on a coordinate plane. Let's see if you can help me fill in the sentences. To find a diagonal distance on a coordinate plane, create a right triangle where the diagonal is going to be, what do we call that? The hypotenuse. That funny word. Hypotenuse, which in ancient Greek means longest side. Or what do we use instead of saying the hypotenuse? Which variable do we always use? Or C. Then use the blank blank. Oh, okay. So you're already thinking about, I'm glad you're thinking that way. You're already thinking of the formula. But what's that theorem we use to do that? A squared plus B squared equals C squared. To calculate the diagonal distance. Okay. So that's basically what we're going to do. We're going to take our knowledge of the Pythagorean theorem, finding missing sides of right triangles, and we're going to find distances on a coordinate plane. Now, this is really, really used all over the place. If you ever have to find a distance on a map, sometimes they use something called triangulation. It's called triangulation because they're literally forming right triangles to find these distances that are too difficult to, measure, go out and measure, like maybe across mountain ranges or things like that. So let's practice. First thing we want to do, take your ruler and let's just connect the points. All right, connect the points. And then we're going to do what we did when we were finding slope using rise over run. So I'd like you to form a right triangle. Okay? So think of going from A to B using rise over run. Okay? I'm going to go here and go vertically up. And then what do I have to do? Go across. Go across. Like so. And now let's find our lengths. These are the easy lengths to find. We can actually measure with confidence. So if I'm going up, how many units did I move up? 5, yeah. I'm going from -2 to 3, so that's 5. And then I'm going to go across from 0 to 4. So 4. And now we use the Pythagorean theorem. Of course, we have our C value. So now we're doing A squared plus B squared equals C squared. So I could put 5 squared plus, what am I going to do next? 4 squared. That's my other leg. Equals C squared. Okay. So now we want 5 squared. 25 plus 16 equals C squared. All right. And that's going to be 25, 41 equals C squared. But that just gives me C squared though. What should I do now? Yeah, square root of 41. Square root of 41. And so that shall give me, well, I have it here already. We want to round this to the nearest tenth though. So, well, we want 2 digits. 41. If this is what I get as an answer, we want 6.4. So now we know the distance from A to B is 6.4 units. And that's something we really couldn't have done just by counting spaces. We could have really tried and probably got very close, but not that accurate. Not as accurate as we would have using the Pythagorean theorem. Okay? So let's try this one, and then I'll leave the third for you to try. So let's try number 2. Let's connect this. Grab your rulers. And there we are. We got to make a right triangle here. Now the slope on this one is pretty steep, right? So that's going to be a little tricky. Let's see if we can do that. This time I think I'm going to go down and over. Down and over. I find that the hardest ones are the finding the length on segments like this that are pretty steep, because counting the lengths can be a little tricky. So that's why sometimes you want to go by the numbers. So let's figure out, I went from 3 down to -4. That's 7. Well, we're just counting lengths though. So it's a total of 7 spaces, correct? So 7 is correct. We want lengths, and those are always going to be positive lengths. And so I went from -4 to -2, this way. From -4 to -2. So how many spaces is this? 2. And of course, see, we have to figure out. Okay. So now let's do the Pythagorean thing. 7 squared plus 2 squared equals c squared. So I heard 49, that's 7 squared, plus 2 times 2 is 4. And 49 and 4 is 53. So now I do have a calculator, and we're all have Chromebooks and phones that have square root features, so that's never an issue, but we could just guesstimate. Square root of 49 is 7, right? This is a little more, so this should be, 7 point something there. 7.2, 7.3. Let's find out. If I only had $1 to give, I'll give you a Hershey's Kiss. 7.3. See me after class. All right, 7.3. But we were pretty darn close. Okay, so the next one I'd like you to try. Okay. Try it, and we'll try to get just up to this portion, and then we'll figure out the square root part. Okay? So give it a try. Yes. No, they didn't ask for it. This is a little extra that I added. All they wanted us to figure out is 9.5, this distance. But quite often we're going to need to find a perimeter and a missing side. So you use the Pythagorean theorem to find your missing side. Then you would find the perimeter by adding up all the sides. Okay. Any questions? Okay. So now let's go ahead and figure out the last thing we're going to do. We're going to save 8 and 9 for tomorrow. And we'll just do these. So on these questions, this is going to be very similar to what we'll be doing on tomorrow's assignment too, by the way. They give you 2 points, and we have to find the distance between the 2 points. So we're going to use the Pythagorean Theorem. So the first thing we want to do is just make these triangles. One second, we're almost done. I'm going to be passing them out while you guys are working here. So while you're finishing that one up, oh, by the way, I have glue sticks here. If you're putting this in your notebook. I'm trying to think. I think Mr. Lepp has visited every class, but he hasn't visited this class. This is the first time, right? Hmm? Oh yeah, Ms. Hahn came at one. Yeah, they're required to visit every. So Mr. Leppe covers all the math department, and he's required to visit every class at least once throughout the year. So I think he's done them all for me. Let's see, he came to first, second. I don't think he's come to third. So maybe he'll come into my third now. I think that's the only one. All right. So hopefully this is what you got. This one here. So I got one side was 7, one side was 5. 5 squared plus 7 squared is c squared. So I got 25 plus 49 equals c squared. That's 74, and we want the square root of 74, which turns out to be 8.6. Okay. All right. We'll do questions 8 and 9 tomorrow. Okay. Now, I want to talk a little bit about the assignment you have for today. If you finish it in class, just turn it in with your name on it. Okay, so this is the assignment. So you'll have to find the square roots either on your Chromebook, or you can borrow a calculator. They're over here by the printer. But the ones that get a little tricky are 4 and 5. They're asking you if it's true or false. And if it is false, whichever one is false, or if they're both false, rewrite the statement correctly in the space below. Okay, so if either of these statements are incorrect, you rewrite it correctly. So notice this one says the perimeter of the trapezoid shown is 22 units. If it's not 22 units, then you would have to say the correct perimeter. And remember, we discussed that in the notes. You have to add all the sides, all four sides. Okay. On questions 6 through 8, one very important fact. I need you to stop for a minute, and it says graph below represents a map where each unit is 0.75 miles. So what that means is, say you find the distance from Jim's house to the grocery store, and say that's 12.75. So whatever distance you find, say that's 12, you would multiply that by 0.75. No. Use the Pythagorean theorem to find the distance. And then once you find the distance, just multiply that by 0.75. So, because when you find this distance using the Pythagorean theorem, all you're really finding is the distance in these units, and just units. But if you wanted to convert it to miles, you multiply by the conversion rate, which is 0.75. So your final answer when they're asking for how many miles is this length that you find using the Pythagorean theorem times 0.75. And that would tell you how many miles that is. Questions? Does that make sense? Find the distance using the Pythagorean theorem, then multiply that by 0.75 to find the miles. Okay? All right, guys. Well, I'll leave you to it. And if you have any questions, let me know.